Hello friends, today I am going to start electrostatics quick revision of 11th standard portion. Now listen here, why this is important, because in 12th standard we have to start with electrostatics, but many concept and many subtopic has been already covered in the 11th portion. So it is necessary to understand that prerequisite concept, formulas and definitions so that you can comfortably handle 12th portion of electrostatics. That's why in this lecture I am going to start quick revision or quick review of that 11th portion of electrostatics. Clear? Okay. First of all, we know that in nature is divided into two categories. First one is what? Matter and radiations. Clear? So any nature is divided into two subparts, that is matter and radiations. Matter can be further divided into two types, charge and mass, and radiations are light. Light is an example of radiations, electromagnetic waves. Now, if you consider matter, matter means what? Anything which occupy space and has weight is called as what? Matter. Matter is what? Anything which has weight and it occupy the space, that is called matter. Clear? Okay. Now important point. In matter, basically mass and charge. Oh, what is the difference? What they really tells us? Charge is a property of matter which shows electrical effects. Clear? So electrical effects of particular object can be studied by using charge concept. Clear? So that's why that charge concept is important in electrostatics. Clear? So charge means what? It is a property of matter itself that shows electrical effects. Clear? So that is called as what? Charge. And mass is the property of the matter which shows gravitational effect. Okay, mass is the property of the matter which shows what? Gravitational effect. Clear? Okay. Another important point was what we have discussed. Charge is associated with mass. Clear? Charge is associated with mass. Okay. So this is the important, what we can say, points about this electrical charge. Clear? So charge is the property of the matter which shows electrical effect. Clear? So mass is associated with charge, but converse is not true. Clear? Mass is associated with charge. If you consider any charge, it has mass, but if you take any mass, it is not necessary that it should be charged or the charge should be present on that particular along with that mass. Clear? So this is a important point. Please listen carefully. Mass is associated with charge. Okay? Clear? But it is not necessary that every mass contains charge. Clear? Okay. Now listen here. Now we have to discuss what? This particular electrostatics with respect to 11th portion in some short quick revision manner. So if you observe, there are some properties of charge that we have that was covered in the 11th portion. What are the properties of charge? First one is additive property of charge, second one is quantization of charge, third one is conservation of charge. What is meant by this? Listen here. Additive means what? Suppose if you take, this is a system, okay, in that case what happens? Suppose there is a total charge of 2 coulombs. Clear? It means what? This 2 coulomb charge basically is what? is this 2 Coulomb charge is a total entire charge on that body. Now that particular body is made up of some small parts, so that each small part contains certain amount of charge, Q1, Q2. Suppose I am taking part 1 of this body, this, part 2 is this, part 2 is 3, part 4 is this. So the total is what? This is Q1, this is what? Q2, this is what? Q3, and this is what? Q4. So total this is what? Q. So Q is equal to what? Q is equal to, if we try to write, Q is equal to Q1 plus Q2 plus Q3 plus Q4. Clear? Q is equal to Q1 plus Q2 plus Q3 plus Q4. Clear? So actually these are the part of this object only, there is no any difference, but that total charge has been added. Okay, so that each part, whatever amount of charge that part contains, if you add all the charges on that each part, you are getting total charge on the body. It means charge is additive. Clear? Okay. Second is what? Quantization of charge. What is meant by quantization of charge? Quantization, what is the meaning of word quantization? Anything that is available in fixed amount. This is called as what? Quantization. Clear? Anything that is available in fixed amount, that is called as what? Quantization. Clear? Suppose the food which you eat, it is not quantized. Okay, so quantize means what? You should count it. It is possible to count in discretized manner. Clear? And another important point is what? In this context, quantization, there is one important point that you have to remember. Fundamental charge. What is a fundamental charge? Smallest charge that can exist independently in universe, it is called as fundamental charge. Independently existence should be there, which is a charge on electron. So charge on electron or electronic charge is a fundamental charge. Clear? Okay, so what is the charge on electron? E, 1.6 into 10 raised to minus 19 coulombs. So these all prerequisite things that you should know while studying this quantization of charge. So quantization of charge, what it tells us, charge on any body, suppose Q is a charge on body, then charge on any body is integer multiple of what? Is integer multiple of fundamental charge. Now I already told you what is fundamental charge. Small, that is the charge on electron. That's why I have written here E, fundamental charge, an integer multiple where n can takes value from, n can be 1, 2, 3, 4 or minus 1, minus 2, minus 3, minus 4. But n cannot be like this 2 by 3 or n cannot be 3 by 5. No, such values are not permitted. Clear? So charge on particular body can be 2e, 3e, 4e, minus 2e, minus 3, but it cannot be plus 2 by 3e or 3 by 5e. Clear? It means it is an integer multiple of electronic charge. Clear? So this is called quantization. Anything that is available in fixed amount, this is called as quantize. Steps. Clear? Okay. Now third one is conservation of charge. What is meant by conservation of charge? You know law of conservation of energy. Clear? Charge neither be created nor be destroyed, only it can be transferred from one body to another body. Clear? Charge neither be created nor destroyed, only it can be transferred. So charge can be transferred. This is also one of the integral property along with it. It can be transferred. Charge can be transferred. Okay. So this is important. This is called as what? Conservation of charge. Clear? So conservation of charge. Okay. It means what? The total charge of an isolated system remains constant. Okay. If you consider this system, then total charge, this is another system. Then suppose there are some charges like 2 Coulomb, 3 Coulomb and minus 2 Coulomb. So, and this is what? Suppose I am taking 1 Coulomb, then it is 2 Coulomb. Now what? If you consider this system, this is entire system. So what is the system here? Total charge. Charge is additive. So if you add this, it only remains what? 3 Coulomb. If you add this 2 plus 1, it is 3 Coulomb. It means total charge of an isolated system. It is a part of one system. Total charge of an isolated system remains constant. So this Q1 plus Q2 plus Q3 is equal to Q1 dash plus Q2 dash. Same. Clear? This is called conservation of charge. Clear? Another some important facts about charge that you might be known or you should know it. Charge is a scalar quantity. Clear? Then unit of charge is what? Coulombs. Charge is denoted by capital Q. That's why the denotion of charge, charge is denoted by capital Q, na? Normally charge is denoted by capital Q, but we can write charge as CH. Charge means what? This, na? CHARG, charge. We cannot denote charge by C, we denote it by Q. Why? Because quantization, we have taken this word, letter Q. Why? Because charge is quantized. Clear? Because it is available in fixed amount. It is integer multiple of fundamental charge. That's why charge is denoted by capital Q. That Q comes from this quantization. Clear? Okay. This is an important point. Okay. So this is about what? Charge and its property. And charge is the intrinsic property of the matter. Clear? Intrinsic means further research cannot be done on it. Intrinsic, basic. We have started from that particular thing. Then we will build new concept from it. Clear? Intrinsic property. Okay. So this is the important points about the charge, electrical charge. Clear? Okay. Now listen here. After that, there was an important law, okay, which was given by Coulomb, that is Coulomb's law of electrostatics. So that Coulomb's law also covered in the 11th portion. What was that law? Coulomb's law plays crucial role when two point charges interact with each other. So basically this Coulomb's law means what? It is the interaction of the two charges. Clear? It means there is one important concept arise, types of charges. So basically there are two types of charges are present. One is positive charge. Clear? Another is negative charge. Plus Q, minus Q. Plus Q, minus Q. So positive, negative. Clear? What is meant by positive charge? What is meant by negative charge? Positive charge means whenever one particular body loses its electron, it means it is now deficient of electron, and due to that deficiency of electron, that body is definitely charged, but it is positively charged. Clear? And another body which gains what? That electron lost by the first body, that second body is now excess of electrons. So excess of electrons is treated as negative charge. Okay, so that's why this is positive charge and negative charge. So this positive and negative charge concept was given by Benjamin Franklin. Clear? Okay. Now in Coulomb's law, definitely another important point was what? Two point charges. What is meant by point charges? This is an important concept. Point charges means what? Suppose these are two charges. Clear? If these two charges are of big, suppose there are two spheres, okay, and these two spheres are kept at very close to each other or nearer to each other. Now these are not called as point charges. Point charges means the charges, clear, whose distance of separation is very large as compared to their sides. Clear? If size is very much less than or it is not comparable with that distance, then in that case that charges are said to be point charge. So when two point charges separated by the distance r, which is a finite distance, and that charges are q1 and q2, then definitely there will be force. Clear? What is the nature of that force? Either attractive or repulsive. When attractive, when these two Q1 and Q2 both the charges are unlike, it means Q1 is positive, Q2 is negative, or Q2 is negative, Q1 is positive. Clear? And the nature of that force is repulsive when both the charges are like. It means Q1 is positive, Q2 is positive, or Q1 is negative, Q2 is negative. Then that force is what? Repulsive. Clear? This is the nature of the force. What is the magnitude of that force? That magnitude of that force is given by Coulomb's law. What it tells? It tells the force of attraction or force of repulsion between 2 point charges separated by the distance r is directly proportional to product of the magnitude of the two charges and inversely proportional to the square of the distance between two charges. It means what? It means F is proportional to Q1, Q2, F is proportional to 1 upon r square. Clear? So that 1 upon r square is called as inverse square law. Whenever r square related with inverse, that time it is called inverse square law. Clear? So that electrostatic force is equal to what? It is proportional to Q1 and Q2 and is inversely proportional to 1 upon r square. And in generalized sense, the formula can be remembered as F is equal to 1 upon 4 pi epsilon naught Q1 Q2 by r square. Clear? Okay. Now, that electrostatic force between 2 point charges is a central force. That force acts along the center of two charges. If these are the two charges and separation is r, Q1, Q2, that force acts along the center of two charges. Clear? That's why these two charges should be point charge. If that is an extended charge, then that force is not central. It may be like this, it may be like this. That's why these two charges should be point charge. Clear? Second, that force acts along the center of the two, that force acts along the line joining the two charges. This is a line joining the two charges. Along that line, that force acts. So it is a central force. It acts along the line joining the two charges. It obeys inverse square law. It means that force is proportional to 1 upon r square. Clear? Another important point was that force is dependent on the medium in which two charges are present. Clear? If that two charges are present in vacuum, force is different. If that two charges are present in suppose water, effect is different. It means what? That force is affected by the medium. As medium changes, that electrostatic force by magnitude changes, and that constant, this is called as electrostatic constant, which is 1 upon 4 pi epsilon naught, where this epsilon naught is called as permittivity of the medium. Okay, that epsilon naught is called as what? Permittivity of the medium. What is meant by permittivity of the medium? Permittivity word, if you consider, that word can be written as permission plus activity. Okay, permission plus activity. What is meant by this? Suppose these two charges are present in suppose what? Water. So that medium, it is a property of medium. It does not deal with charges. So that water means whatever that medium, it is a water. So field of it, that medium allows its field for what purpose? That it gives permission to, medium gives permission to its own molecules. Water will give permission to its own molecule for what? To oppose or to weaken the interacting force between two charges. So that the force between two charges is opposed or decreased by whom? That medium water. So it is a permission of whom? It is a permission of that medium for activity. What is the activity? Decreasing the interacting force between two charges. So this is called as permittivity. Clear? And that permittivity value epsilon naught is 8.854 into 10 raised to minus 12 Coulomb square upon Newton meter square. Clear? What is meant by permittivity? permission plus activity. It is related with what? It is related with medium in which two charges are present. So effect of medium on electrostatic force. Clear? Okay. Now listen here. Now this 4 pi comes. What is the reason 4 pi? As this particular charge, what is the shape of that charge? It is assumed to be spherical. If it is assumed to be spherical, it means that field or the force will be experienced in all sides. So that force, effect of force on the all sides, it means we have to take what? Surface area of sphere, and surface area of sphere is what? 4 pi r square. So that 4 pi means it is a solid angle subtended by the sphere at the center. That's why this 4 pi comes. Clear? So this is called electrostatic constant 1 upon 4 pi epsilon naught, and epsilon naught is called as permittivity of medium, which is 8.854 into 10 raised to minus 12 Coulomb square upon Newton meter square, and the value of 1 upon 4 pi epsilon naught is comes for vacuum comes out to be 9 into 10 raised to 9 Newton meter square upon Coulomb square. Clear? 9 into 10 raised to 9 Newton meter square upon Coulomb square. Clear? It means what? Electrostatic constant having very large value. What is the order? What is the order of this particular order of this magnitude? That is 10 raised to 10. It is in order of 10 raised to 10. So what happens? In generalized sense, nature always supports electric field. Why nature always supports electric field? Because it is a value of electrostatic constant for vacuum or air. So that in generalized sense, nature supports electric field because K is in the order of 10 raised to 10. Clear? So this is the important about what? Your Coulomb's law. Okay? Yes. Now, principle of superposition. What is the principle of superposition? This is an important formula for only two charges. If suppose there are 4 charges and Q1, Q2, Q3, Q4 are present, I want to calculate force on one charge, force acting on one charge number 1. In that case, what is the option? Listen here. In that case, suppose this is a charge Q1, Q2, Q3 and Q4. I want to find out the force on 1 due to 3, I want to find out the force on 1 due to 2, and I want to find out the force on 1 due to 4. It means what? In a system of charges, if more than 2 charges are present, in that case, if I want to calculate the net force on any charge, which is equal to what? Which is equal to vector sum of the forces exerted by remaining charges on that particular charge. Q1, on Q1 charge, what is the force exerted by Q2? That is F12 bar. On Q1 charge, what is the force exerted by Q3? F13 bar. On Q1 charge, what is the force exerted by Q4? That is F14 bar. Clear? So this is called as, this is the principle of superposition. Clear? Okay. Now this is the principle of superposition. Then there was a concept of field. What is meant by field? The space around the charge in which electrical influence is felt. It is called as what? Field. If there is a charge, then the region around which the influence of the charge is felt. What is the boundary? What is the line of demarcation? That tells us that charge is affected in that particular region. That region is called as what? Field. Clear? Then we discuss electric field intensity. What is meant by electric field intensity? Electric field intensity is actually what? It is a force per unit test charge. Now another concept, test charge. Test charge is the smallest positive charge, okay, who does not create his own field. So in this formula, actually this formula can be read as electric field intensity is equal to force experienced by this test charge. By whom? Source charge. So if this is a charge and this is the smallest charge, test charge, then how much force this charge Q exert on the smallest charge? This is called as electric field intensity. Clear? So this is the what? What is the unit of the Newton per Coulomb? It means what? Suppose 1 Newton of force is experienced by the 1 Coulomb of test charge. Suppose this is 1 Coulomb and this particular force is what? 1 Newton. If 1 Newton force is experienced by this 1 Coulomb test charge, then electric field intensity of that source charge or 1 Newton per Coulomb. Clear? So it is a test charge. Test charge is the smallest charge. Test charge is positive. Test charge does not create its own field. Otherwise, what happens? If it generates its own field, then it disturbs the source charge, and its field also interfere with that source charge field. Clear? So this is called as what? Electric field intensity. Electric field means space around the electric charge in which electric influence is felt. What is electric field intensity? What is the strength of that field? What is the strength? Okay, field is present. Now what is the strength of that field? That strength is called as intensity. It means what? It is related with area. Clear? Intensity means what? Area means suppose the field is, suppose there is one particular what I can say power energy I am striking, or suppose beam of light is focused. If that beam of light is focused on smaller area, then that focus is more. But if it diverge on wide area, then that beam of light is not that much focused. It means what? Intensity related with area on which that focus is falling. It means if there is a field, then there is a question of calculation of intensity. If there is field is absent, what is the use of that intensity? Clear? So this is about what? Electric field intensity, strength of the field. First you have to check whether there is a field. Okay, field is present. Then what is the strength of that field? Intensity. Electric field intensity. Clear? Okay. So this is about what? Electric field intensity. So these two are important prerequisite which we require in our 12th portion. Clear? Okay. Then after discussing electric field, there is an important word, important concept, electric lines of force, LOF. Clear? If electric field is present, actually what happens? Suppose there is a charge Q, and if this is test charge, it experiences a force. It means actually what happens? This is explained by Faraday's. So Faraday is what? Faraday told that the charge or the particular lines of force is the path, dedicated path along which charge would travel. If this is a charge, then there is one path along which that charge will move if it is set in free motion. So it means it is a prediction. Charge will move along this path. So that path along with the unit positive charge will move is called as lines of force, or these are the imaginary lines. Okay, another important point about what electric lines of force, they never intersect each other. Clear? Or they never cross each other. Okay, another important point, they does not pass through the conductor. They passes always through insulator, or they terminates on conductor, because they inside the conductor electric field lines are zero. Clear? If electric field lines are crowded, it means intensity is maximum. If electric field lines are wide, in that case intensity is minimum. It means intensity related with field lines. If field lines are closer and closer, electric field intensity is more and more. Clear? Okay. So after the electric lines of force, such large number of electric lines of force gives electric flux. Such large number of electric lines of force, what gives us? Electric flux. It means what? So electric flux relates electric field intensity along with area. Clear? It means what? How much electric field lines passing through particular area, that measure is given, that particular quantity is called as electric flux. That's why formula is what? E bar dot dA bar. Now after discussing electric flux, now we will discuss what is the unit of electric flux. So we know that electric flux phi is equal to E bar dot dA bar, where E is in Newton per Coulomb into area is meter square. So what is the unit of electric flux? Newton meter square upon Coulomb. Or what is the unit of electric field intensity? Volt per meter. So it is volt per meter into meter square. So it is volt meter. So volt meter is the unit of electric that is electric flux or magnetic flux. Clear? Okay. Now important point that we have to discuss is what? In uniform electric field, basically there are three types of charge distributions are used to represent a continuous charge. Because as I already discussed with you, charge is continuous, it is not discrete. So these three types of charge distributions, which are linear charge density, surface charge density and volume charge density. So this linear charge density is lambda is equal to Q upon L, which is in Coulomb per meter, and the surface charge density is sigma, which is what? Charge per unit area. What is area? Meter square, so it is Coulomb per meter square. And volume charge density is what? Charge per unit volume, that is Coulomb per meter cube. So these are the three charge densities. What is the significance of each, that we have to discuss. Suppose there is a one wire on which charge is distributed uniformly, and we have to determine the total particular charge on that particular wire or ring. In that case, what happens? We will make use of this formula, that's lambda is Q by L. It means whenever 1D shape is there and you have to determine the charge, you can use this type of charge distribution, that is linear charge density. So for 1D, linear charge density. Second, if there is a 2D distribution, that is, suppose there is a plain sheet and charge is distributed on that sheet, in that case the surface charge density sigma is what? Q upon A, okay, where Q is charge and A is area. And suppose there is a cube or sphere and charge is distributed, then how to calculate the total charge? Using what? Rho is equal to Q upon V, where Q is in coulombs and volume is in meter cube, so it is Coulomb per meter cube. So these are the three types of charge distributions that are used to calculate the total charge, okay, present on that particular structure. Clear? So because what? If you consider antenna, so there is a charge distribution of antenna means continuous, that time you have to use what? Suppose in 3D you have to use volume charge density. Clear? So in this way these distributions are used to calculate the charge. And actually if you consider this charge per unit length, it means what? If there is a 10 meter wire and suppose for 1 meter there is a 1 Coulomb charge, so for 10 meter 10 Coulomb charge. It means you can, if you are comfortable with a unit rate, you can definitely calculate any rate, okay, that is per square meter there is a rate of 50, so you can calculate for 10 meter square. So it means for unit quantity, if you know the charge density, then you can calculate it for all any other given measure or any other given quantity using this linear charge density. Clear? So any random calculation of charge can be done using this charge densities. Clear? Okay. So after discussing the charge densities, now I am going to discuss electric dipole. What is meant by this electric dipole? Electric dipole means, as name itself suggests, it consists of what? Two charges separated by some distance. What are the two charges? Plus Q and minus Q, and these two charges are separated by the distance of 2L. So in that case it forms a dipole. What is the dipole moment? P bar is equal to Q into 2L bar. Means what? If you take the product of any one of the charge and multiply it with the length of dipole, in that case you will get the dipole moment, and its unit is what? Coulomb meter. And this dipole moment is the identity card of that particular electric dipole. It is the identity of electric dipole. Clear? Okay. Now next important point is torque acting on a dipole. What is the formula for torque? P bar cross E bar, means in magnitude form it is torque is equal to PE sin theta, where theta is the angle between axis of dipole and electric field. So if sin theta is equal to 0, it means torque experienced by that dipole is 0. If theta is 90, then torque experienced by that dipole is PE, which is maximum. It means what? Dipole has tendency to align itself along with electric field, because if theta is 90, in that case it experiences maximum torque. So that time what happens is it tries to rotate that dipole in the direction of the electric field. It means every dipole has tendency to align itself in the direction of electric field. So if theta is 0, so torque is 0 because it is already with the electric field. Theta 0 means parallel with the electric field. So there is no torque is required. Clear? So this is about torque. Now last important point is electric field. For the electric dipole, we have to consider two important cases. First one is along the axis, second one is along the equator. What is the along the axis formula for electric field? E is equal to 1 upon 4 pi epsilon naught 2p by r cube, in which this 1 upon 4 pi epsilon naught is an electrostatic constant and this p is the dipole moment, and r is the distance of that point which is along the axis of dipole from the center of dipole. Clear? And this formula is valid only for short dipole. Short dipole means what? Whose length is less than the distance at which you are supposed to calculate the electric field. Now electric field along the equator of dipole, what is the formula? E is equal to 1 upon 4 pi epsilon naught p by r cube. So if you try to correlate these two formulas, then electric field along the axis of dipole is twice the electric field along the equator. Clear? So in this way, this is the entire quick revision of electrostatics, which is a part of 11th syllabus, but this is a prerequisite to understand all the concepts which are included in this particular revised syllabus of physics 2 in electrostatics. Clear? So revise all the notes given in this lecture, try to recall it, and remember all the formulas which are given in this lecture, which are also useful in your competitive exams. Thank you.